December 8, 1941. Imperial Naval Headquarters, Tokyo. Admiral Osamu Nagano reviewed the reports from Pearl Harbor with grim satisfaction. 8 American battleships crippled or destroyed. Nearly 200 aircraft ruined. 2,400 Americans killed. The American Pacific Fleet lay shattered. What Nagano could not know, what no officer in the Imperial Japanese Navy could have imagined, was that aging vessels rusting in America's reserve fleets were about to become part of history's most extraordinary naval expansion. Within 2 years, American shipyards would reach production rates that Japanese naval planners had considered physically unimaginable, launching ships faster than the Imperial Navy could even record, much less destroy. The awakening of the reserve fleets. The James River Reserve Fleet near Fort Eustis, Virginia, represented one of several American ship graveyards, where vessels from World War I lay in various states of preservation. These ships, exact numbers uncertain, but likely over 100, had been only minimally cared for through the 1930s as congressional funding declined. They existed in a limbo of bureaucracy, too valuable to scrap, too expensive to properly maintain, seemingly too outdated to matter. The morning of December 8th revived this maritime cemetery. Workers from Norfolk Naval Shipyard and civilian contractors descended upon the anchorage. The reactivation orders were stunningly straightforward yet seemingly impossible: return every feasible vessel to service at once. Initial inspections revealed formidable challenges. Engine rooms flooded. Machinery corroded beyond recognition, bird nests filling ventilation ducts. Some ships even had vegetation sprouting on their decks. Yet within weeks, vessels began moving under their own power. The USS Bridgeport, originally a German liner seized in 1917, was among the earliest revived, black smoke billowing from stacks that hadn't tasted flame in more than a decade. By spring 1942, dozens of ships had been pulled from reserve, refurbished, and returned to duty. These were not glamorous warships, but auxiliary vessels, repair ships, tankers, cargo carriers, and transports that would become indispensable. Their reactivation provided immediate reinforcement at a moment when America needed every hull that could remain afloat. The intelligence failure in Tokyo. The Imperial Japanese Navy's intelligence network, its size debated but clearly understaffed, attempted to evaluate American capacity. Their pre-war analysis suggested the United States might build perhaps 500,000 tons of naval vessels annually, with possibly 2 million tons of merchant shipping under maximum effort. The reasoning appeared sound. Japanese analysts counted American shipways, gauged steel production, and assessed labor availability. Naval attaches who had served in Washington reported on American inefficiencies, labor disputes, racial tensions, and peacetime complacency. One report observed that American shipyards operated far below capacity and that workers resisted overtime. These observations, accurate for peacetime, completely misread American potential. Japanese analysts saw labor disputes without imagining those same unions pledging no strike agreements for the entire war. They saw racial segregation without foreseeing the war creating new opportunities, however limited, for minorities in defense industries. When intelligence officers suggested higher American capacity, their assessments were often dismissed. The prevailing strategic doctrine, the Kaikessen or decisive battle concept, assumed the conflict would conclude within a year through a single, climactic naval showdown. Long-term American industrial power seemed irrelevant if the war would be settled before new ships could be launched. By 1943, America would produce more than 19 million tons of shipping, nearly 10 times what Japanese planners believed feasible. This was not merely an Intelligence shortcoming, but a catastrophic misunderstanding of American society's ability to mobilize at scale. The Maritime Commission's mobilization. The United States Maritime Commission transformed almost overnight from a New Deal bureau managing merchant marine decline into the coordinator of an unprecedented shipbuilding surge. Admiral Emery S. Land, the Commission's chairman, understood both engineering and government machinery. His declaration was simple: build ships faster than they can be sunk. The Commission's expanded wartime authority allowed it to commandeer shipyards, allocate materials, direct labor, and coordinate the entire production ecosystem. This coordination, invisible to Japanese intelligence, focused on counting ships, would prove as important as the ships themselves. The Liberty ship program, based on a British design for simple cargo vessels, established the template for mass production. The design deliberately employed older technology, reciprocating engines instead of modern turbines, straight lines instead of complex curves. These ships were optimized for rapid construction by inexperienced workers. The first Liberty ship, SS Patrick Henry, launched September 27, 1941. Required 244 days to complete. By early 1942, construction time had fallen below 100 days. By late 1942, some yards were completing ships in under 50 days. The learning curve was steep and continuous. The Commission also addressed the human element. New training programs could transform farmers into able seamen in weeks. The Merchant Marine Academy accelerated its program from 4 years to 18 months. By war's end, over 250,000 new merchant mariners had been trained, creating from nothing a merchant marine larger than Japan's entire maritime workforce. The Kaiser Revolution. Henry J. Kaiser entered shipbuilding with no maritime experience, but with revolutionary ideas from building dams. His approach was simple: break complex projects into simple tasks, maximize parallel work, and invest in workers. At his Richmond, California yards, 4 separate facilities that would eventually contain 55 shipways total, Kaiser implemented assembly line ship building. Traditional shipyards built vessels sequentially from keel up. Kaiser built ships in sections simultaneously. Bow sections were constructed while stern sections were built elsewhere. Deck houses were completed off-site, fully equipped, then lifted into place. The workforce transformation was equally revolutionary. When skilled ship builders proved scarce, Kaiser didn't lower standards. He redesigned the work. Instead of training complete ship builders, he trained specialists. A welder might master only one type of joint but perform it perfectly thousands of times. Kaiser created supporting infrastructure to eliminate bottlenecks. When housing proved inadequate, he built entire cities. When workers needed healthcare, he created what became Kaiser Permanente. When childcare was lacking, he built 24-hour nurseries. Every obstacle to production was identified and eliminated. By mid-1942, Kaiser's yards were completing Liberty ships in remarkable time. While claims of specific record-breaking construction times should be viewed cautiously, the sustained pace of production was undeniable. The Richmond yards alone would produce over 700 vessels during the war. Pearl Harbor's paradox. The Pearl Harbor attack, while tactically successful, contained strategic miscalculations. Admiral Yamamoto Isoroku, the attack's architect, understood American potential better than his superiors. Having studied at Harvard and served in Washington, Yamamoto had seen American industrial capacity firsthand. His oft running wild for 6 months or a year reflected this understanding, though the famous sleeping giant quote attributed to him is likely apocryphal. The attack's immediate success seemed to validate Japanese planning, but critical elements were missed or ignored. The Pacific fleet carriers were absent. More importantly, Pearl Harbor's infrastructure, repair facilities, fuel storage, submarine base remained intact. These facilities would enable rapid recovery. Most significantly, Pearl Harbor unified American opinion instantaneously. Pre-war America had been divided and isolationist. The attack transformed this overnight. Workers who might have resisted over time now worked double shifts. Unions suspended strike actions. Women entered the workforce in unprecedented numbers. The production statistics reflect this transformation. Ship deliveries accelerated monthly throughout 1942. Each increase represented not just more shipyards coming online, but existing yards becoming more efficient, workers becoming more skilled, and systems becoming more refined. The production surge. By mid-1942, American shipyards were achieving what Japanese planners deemed impossible. Monthly Liberty ship completions rose steadily. 5 in January, 14 in March, 33 in June, 67 in September. The peak came in October 1943 when 106 Liberty ships were completed, more than 3 per day. Japanese intelligence struggled to process these numbers. When neutral sources reported hundreds of new American vessels in Atlantic ports, Japanese analysts suggested various explanations. The Americans were counting the same ships multiple times, including Great Lakes vessels, or simply lying. Any explanation seemed more plausible than accepting the reality. Each Liberty ship represented enormous coordination. Thousands of tons of steel had to be delivered in proper sequence. Engines from multiple manufacturers had to arrive precisely when needed. Components from hundreds of suppliers had to flow without interruption. The organizational capability this represented was as impressive as the ships themselves. Meanwhile, reactivated reserve fleet vessels provided crucial support. Repair ships could return damaged vessels to service without lengthy voyages to shipyards. Tankers extended operational range. Ammunition ships, despite their dangerous cargo, maintained the supply of ordnance that American firepower doctrine demanded. Submarine perspectives. Japanese submarine commanders provided the most direct witness to American expansion. Their war patrol reports, often dismissed by superiors as exaggeration, documented the transformation of American naval power. Commander Kanashi Takazuwa by 19 achieved spectacular success in September 1942, sinking the carrier USS Wasp. But his subsequent patrols reported increasingly difficult conditions. Larger convoys, denser escort screens, continuous air patrols. By 1943, attacking American convoys had become nearly suicidal. The evolution of American anti-submarine warfare, enabled by industrial abundance, transformed the Pacific. Escort carriers, many converted from merchant hulls, provided air cover far from land. Destroyer escorts produced in hundreds hunted submarines relentlessly. Radar and sonar improved continuously. By late 1943, Japanese submarines had largely shifted from offensive operations to supply runs for isolated garrisons. The hunters had become the hunted, forced to avoid detection rather than seek targets. One commander noted bitterly that the Americans seemed to have built a destroyer for every ton of rice in Japan. The shipyard ecosystem. The Kaiser shipyards exemplified American production methods at their peak. The Richmond complex operated continuously, with day and night shifts maintaining constant activity. The prefabrication system had evolved to remarkable sophistication. Major ship sections were built in separate assembly areas. Bow sections weighing over 200 tons were constructed as units. Stern sections were built with propeller shafts already installed. Deck houses arrived fully equipped with plumbing and electrical systems. These sections were then assembled on the shipways like giant three-dimensional puzzles. The workforce included unprecedented numbers of women, reaching 25 to 30% in some yards, and minorities. While discrimination persisted and opportunities remained limited, the war had opened industrial jobs previously denied to these groups. The average worker had less than a year's experience, yet productivity exceeded pre-war standards. Supporting infrastructure was equally impressive. Miles of railroad track moved materials. Massive cranes, some specially built to handle weights traditional ship builders said couldn't be lifted, moved sections into place. Machine shops, foundries, and assembly areas operated in coordinated sequences. Strategic recognition within Japanese leadership. Recognition of inevitable defeat came at different times but followed similar patterns. After initial successes, gradual doubt emerged, followed by sudden acknowledgement of mathematical impossibility. The Marana's defeat in June 1944 marked a turning point. The Battle of the Philippine Sea, dubbed the Great Marianas Turkey Shoot by American pilots, demonstrated overwhelming American superiority. Task Force 58 brought more carriers, battleships, and escorts than the entire pre-war Imperial Navy. Japanese naval aviation was effectively destroyed, losing over 400 aircraft while shooting down fewer than 30 American planes. Admiral Toyota Soimu, commanding the combined fleet, later acknowledged that after the Maranas, he knew the war was lost. The Americans had built a navy Japan couldn't fight, supplied by merchant fleets Japan couldn't sink, supported by industry Japan couldn't match. The appearance of B-29 bombers over Japan in late 1944, flying from Marana's bases, made American superiority visible to civilians. While Japanese fighters could reach B-29 altitudes with difficulty. They rarely successfully intercepted these raids. Each bomber represented American industrial capability, complex, expensive, mass-produced. The victory. Ship evolution. Even as Liberty ships poured from shipyards, the Maritime Commission implemented improvements. Victory ships addressed Liberty ship limitations while maintaining mass production advantages. They were faster, stronger, and more efficient. The key improvement was speed. Liberty ships 11, not maximum, made them vulnerable to submarines. Victory ships could achieve 15 to 17 knots, enough to outrun surfaced submarines and reduce voyage times significantly. Hull design improvements eliminated structural weaknesses that had caused some Liberty ships to develop cracks. Production transition demonstrated American adaptability. Shipyards switched from Liberty to Victory production without significant delays. Workers adapted to new techniques while maintaining productivity. By mid-1944, Victory ships were being completed as quickly as the simpler Liberty ships had been built earlier. Over 500 Victory ships would be built, many serving decades after the war. Their durability validated the mass production approach. Quantity hadn't sacrificed quality when properly managed. Social transformation. The shipyard workforce represented dramatic social change. Women performed jobs previously considered impossible for them. Welding, riveting, crane operation. African amines found opportunities, though limited by persistent discrimination, in skilled positions previously denied them. Kaiser's innovations extended beyond the shipyard. His healthcare system, established to keep workers healthy and productive, pioneered prepaid medical care. Child care centers operated around the clock. Housing projects created instant communities. Vanport City near Portland housed over 40,000 residents at its peak, becoming Oregon's second largest city virtually overnight. These social support systems weren't charity, but calculated investments in productivity. Healthy workers were productive workers. Workers with childcare could work any shift. Workers with housing near shipyards spent less time commuting. Every barrier to production was identified and addressed. The productivity achieved was remarkable. Man-hour per ship fell continuously as workers gained experience and systems improved. By late 1944, a Liberty ship required about one-third the labor hours of early 1942 construction. This wasn't just efficiency, but transformation of work itself. The mathematics of defeat. By 1945, the arithmetic of American victory was undeniable. The Philippines campaign demonstrated American ability to project overwhelming force anywhere in the Pacific. Invasion. Fleets numbered hundreds of vessels, supported by supply trains that stretched across the Pacific. At Uwima, concentrated American firepower exceeded anything in military history. The preliminary bombardment expended more ammunition than many nations possessed in total. At Okinawa, the assembled fleet exceeded 1,400 vessels, likely the largest naval concentration ever assembled. The Kamikaze Campaign. Japan's desperate attempt to inflict unacceptable losses through suicide. Attacks achieved tactical successes, but strategic irrelevance. Dozens of ships were sunk, hundreds damaged. In previous wars, such losses might have halted operations. Against American industrial output, they were absorbed and replaced without strategic impact. By summer 1945, American naval forces operated with casual abundance. That would have seemed fantastical in 1941. Damaged ships were repaired and returned to service. Lost ships were replaced. The mathematics had become insurmountable. Industrial victory. The atomic bombs that ended the war obscured a fundamental truth. Japan was already defeated by conventional industrial warfare. The bombs accelerated surrender but didn't cause defeat. That had been determined in American shipyards. Between December 1941 and August 1945, American shipyards produced over 5,000 merchant vessels totaling more than 50 million deadweight tons. Japan produced a fraction of this. America built more ships in single months than Japan built in entire years. The disparity extended beyond mere numbers. American ships incorporated continuous improvements. Quality control improved even as quantity increased. Innovation continued throughout mass production. This combination, quantity, quality, and continuous improvement proved insurmountable. Admiral Land's Maritime Commission had orchestrated victory through logistics. Ships were built faster than enemies could sink them. Crews were trained faster than enemies could kill them. This was victory through industrial arithmetic. The reckoning. Post-war interrogations revealed how Japanese officers gradually recognized defeat's inevitability. Early victories had seemed to validate strategy, but each subsequent engagement showed Americans stronger while Japan grew weaker. One senior officer provided a stark timeline. After Midway, we had lost the initiative. After Guadalcanal, we had lost momentum. After the Marianas, we had lost the war. After the Philippines, we awaited the end. After Okinawa, we prayed for it. The home front's recognition lagged, but followed inevitably. Government propaganda maintained victory claims. Even as cities burned, but B-29 raids, naval bombardment, and submarine blockade made reality undeniable. By spring 1945, most Japanese understood the war was lost, though few dared voice this recognition. The refusal to acknowledge mathematical reality caused hundreds of thousands of unnecessary deaths. Continuing resistance against impossible odds wasn't strategy, but denial. The atomic bombs provided a face-saving excuse to end what American shipyards had already decided. Lessons and legacy. The reserve fleet reactivation and subsequent ship building surge demonstrated capabilities that transcended traditional military calculations. Democratic societies, when unified, could achieve mobilizations that authoritarian planners couldn't imagine. The production techniques developed prefabrication, modular assembly, workforce specialization influenced global manufacturing for decades. The social changes, women in industry, minorities in skilled positions, employer-provided health care, reshaped American society permanently. Japanese intelligence's failure wasn't primarily about gathering information, but about processing it. Cultural assumptions and strategic doctrine created filters that prevented accurate assessment. They could count ships, but couldn't imagine the system producing them. They could see factories, but couldn't envision their transformation. They understood tactics, but not logistics. The contrast was stark. Japan brought sophisticated tactics, experienced crews, and spiritual determination. America brought industrial capacity, organizational capability, and mathematical inevitability. In modern industrial warfare, production mattered more than courage, logistics more than tactics, and arithmetic more than spirit. Conclusion: when democracy mobilized. The story of America's reserve fleet reactivation and the industrial expansion it represented reveals how World War II was won. Not through dramatic naval battles alone, but through shipyards, steel mills, and training centers across America. The aging ships that returned to service in 1941 were part of a transformation that would reshape global power. The Japanese miscalculation wasn't simple intelligence failure, but fundamental misunderstanding of American society's capacity for mobilization. They saw PCM inefficiency without recognizing wartime potential. They counted ships without understanding the system that would produce them. They prepared for a war of maneuver and clashes while America prepared for a war of manufacture. Henry Kaiser and others didn't just build ships, they re-engineered production itself. Their methods would influence industry worldwide. The social changes they set in motion would reshape American society. The organizational capabilities they revealed would define modern logistics. The human dimension includes both achievement and sorrow. American workers accomplished production feats. Japanese forces fought bravely against statistical impossibility. Civilians on both sides paid war's cost, but the result was decided by industrial capacity, not battlefield heroism. The lessons remain pertinent. Industrial strength still anchors military power. Manufacturing capabilities still shaped strategic choices. Democratic nations still possess mobilization potential that surprises those who see only their peacetime shortcomings. The reserve fleet vessels that returned to duty in 1941 carried more than cargo across the Pacific. They carried evidence that industrial democracy could shift from peacetime inertia to wartime supremacy with a speed and magnitude that shattered every assumption about modern warfare's limits. In shipyards across America, workers built not only ships but an emerging world order, one hull at a time. The mathematical truth was straightforward. America could build ships faster than Japan could sink them, train crews faster than Japan could eliminate them, and produce supplies faster than Japan could destroy them. This was not simply victory, but a redefinition of warfare. The age of decisive naval duels had ended. The era of industrialized conflict had begun. Japan learned this through devastating loss. The empire that appeared unstoppable in December 1941 lay in ruins by August 1945, defeated not by superior tactics but by superior capacity. Not by greater bravery, but by greater output. The reserve fleets that rose from American waters had triggered an industrial tidal wave that turned the Pacific War from a military contest into mathematical inevitability. The final irony is that Japan's post-war recovery would adopt the very methods that had undone its empire. Japanese shipyards embraced American production techniques. Japanese industry adopted mass production. The lessons of the war transformed Japan from military titan to economic powerhouse, proving that the industrial tools that win wars can also win peace. Ultimately, the story of America's Ghost Fleet is not merely about ships, but about the transformation of warfare itself. When industrial strength aligns with national resolve, when democratic societies mobilize for total war, when production becomes strategy, traditional military calculations become irrelevant. The reserve fleet vessels that re-entered service in 1941 didn't just help win a war. They proved that in the modern era, the factory floor could be as decisive as the battlefield, the assembly line as vital as the battle line, and industrial math the final judge of victory.